Hello and welcome to It's Science. Today in It's Science we are going to explore some simple physics behind this common toy. This is a Slinky, which is a simple spring, and this is a very common toy which we have played with in our childhood. Now it's time to do some physics with the Slinky. A Slinky is nothing but a simple spring where each coil touch the other. When a Slinky is at rest, all the coils touch each other. But let me show you the fall of Slinky under gravity. When you hold it in mid-air, it readily stretches. When I drop the Slinky, let me show you what happens. Now I have put some weight on the bottom portion of the Slinky. I will drop the Slinky again and I will show you the same thing repeats. When a Slinky is held mid-air, then the downward gravitational pull is balanced by its upward tension. Center of mass of this Slinky lies between the top and the bottom portion. When I release the Slinky, the information that I have released it come down in the form of wave, just in case of waves travel when a bomb blasts. And when all the information travels downward, the Slinky gets compressed and they fall as a unique system. Now, what is so special about this Slinky is that when I release it, it is held mid-air for about 0.3% or so. I have given a link of the paper where the calculation is done. And the thing is, this levitation time does not depend on the position of drop of the Slinky. If you drop it on Earth, if you drop it on the Moon, if you drop it on Jupiter, then irrespective of the gravitational pull of that particular planet, the levitation time remains the same. The levitation time depends only on the mass and the spring constant, that is the stiffness of this spring. But for metal Slinky, it will be different. As the center of mass of the Slinky lies between the top and the bottom portion. So when I release the Slinky, the center of mass keeps on accelerating and it is falling towards the ground without violating any of the Newton's laws of motion. When the Slinky is held from top, the bottom comes to rest at a point of equilibrium where the spring can't be stretched more due to gravity. And due to gravity, the spring does not pull the bottom up any higher than this balanced length. Slinky is handheld. There are three types of forces acting on the Slinky. At the top, there is a force by the hand which is acting upward. And for the rest part of the Slinky, there are two forces. One is tension and other is the weight of the Slinky mg, and they both are acting downwards and they are in perfect balance with each other. When the Slinky is released, the force by the hand is now zero, but at the top the two forces are still acting, which is tension and the weight of the Slinky. At the bottom, the forces are still balanced. That's why the bottom portion of the Slinky remains at rest. Normally, both ends of a spring will usually move toward each other. That is its property. But when we release the top end, unless one end is still being held, in this case, the spring is being held by gravity. So what we can see is the top comes down faster than we expect from free fall, because we have the effect of gravity plus the effect of the spring wanting to compress, and these two forces are working at the same time. The bottom wants to go up but can't. Then it would have to overcome gravity. And every instant of the fall, the spring is becoming less stretched, and therefore the spring constant is diminishing. So, a simple toy and some simple physics. Thanks for your time.